So let's try another example using the elimination or the addition method to solve a system of equations. Now let's say I give you 3x plus 4y is equal to 17 as the first equation, and then minus x plus 2y is equal to 1 as the second equation. Now notice that if we add these two together, none of the variables are going to cancel out. But if I multiply the second equation by 3, as in multiply each term by 3, then we're going to get a negative 3 in the second equation and then a positive 3 as the coefficient for the x in the first equation. So the x's are actually going to cancel out. So let's do that, rewriting the equations. So let's just rewrite the top as normal, because it doesn't need to change. Oops. I don't like the way that x looks. Let's write it again. Alright, better. And then for the second equation, let's multiply each term by 3. So for the first term, we get minus 3x. For the second term, we get plus 6y. And then the third term, we just get 3. Remember, you have to multiply both sides of the equation by 3, because if not, then you'll technically be changing the equation, which is not what we want to do. So now, let's add these two together. The positive 3x and the negative 3x are going to cancel out and give us a 0. And then here we get 10y equals 17 plus 3, which is 20. So now our new equation looks like 10y is equal to 20. So now we have a linear equation in one variable, which we're really used to solving. So dividing both sides by 10, we get that y is equal to 20 over 10, which is otherwise known as 2. So now we've solved for the y, but again remember that these equations are in two variables, so we need to solve for x. And the way we do that is to plug in y equals 2 into one of the equations. You can plug it into both, but you're going to get the same answer for x. So I'm going to plug in, let's say the second equation. So letting y equals 2, we end up getting minus x plus 2 times 2 is equal to 1, or minus x plus 4 is equal to 1, which means minus x is equal to minus 3. And then dividing both sides by negative 1, we end up getting that x is equal to 3. So now we have both our solutions for x and y to solve the system, and what we want to write at the end is writing our solution in terms of an ordered pair, where it's x comma y. So the solution is 3 comma 2.